Hello, welcome again. We are solving Indian Forest Services Mechanical Engineering Paper 1 of year 2021. Question number 2C. Classify the point defect of a crystal structure and define each point defect with the help of suitable diagram. So first part, point defect. The point defects are zero dimensional defects when an atom is missing or an atom is in an irregular place in the lattice structure. The corresponding defects are known as point defects. A point defect produces strain in small volume of the crystal surrounding the crystal but does not affect the perfection distant parts of the crystal. In general, point defects occur in metallic and ionic crystals. Point defects are of following types. First is vacancies, second is interstitial defects, third is substitutional defect, next is Frankel's defect, and last one is Scotty defect. So uh, first is vacancies. Vacancies are simplest point defect in the crystal which refer to missing atom at its site. Definition: the defect due to missing atom at their lattice are called vacancies. So this is the vacancy. The atom is not there. A crystal lattice with vacancy defect is shown in figure. Vacancy defects are mainly due to imperfect packing during the formation of crystal or due to thermal vibration of atoms at high temperature. At high temperature, atoms are frequently and regularly change their position, leaving empty lattice sites behind their position. For most crystal, thermal energy is of order of 1 electron volt per vacancy. Next is your interstitial defect. Definition: when an impurity atom tries to settle in the interstitial space between the parent atom of the crystal without displacing, then such a defect is known as interstitial defect. The interstitial impurities are much smaller than atoms in the bulk matrix. The formation of interstitial impurity defect is shown in figure. So this is your interstitial for an atom. Formation of interstitial impurity defect is shown in figure. Examples are: carbon atoms are interstitial impurity atoms that are added to iron to make steel. In steel, carbon atoms with radius of 0.071 nanometer are well fitted in the interstitial spaces between the larger iron atom of radius 0.124 nanometer. The number of vacancies per unit volume of crystal depends upon temperature. In most cases, diffusion, mass transport by atomic motion, can occur because of vacancy. In case of ionic crystal, there are two types of point defects related to vacancies. They are Scotty defect and Frankel defect. First of all, Scotty defect. It is special case of vacancy defect in ionic crystal. Definition: when a pair of vacancies is produced at one positive ion site and one negative ion site due to absence of positive and negative ions, then this type of defect is called Scotty defect. In ionic crystal, there are two types of possible vacancies, namely cation positive ion vacancy and anion negative ion vacancy. When a positive ion from the interior of the lattice move out of the crystal to its surface, then a positive vacancy is formed at the site. The formation of positive ion vacancy results in excess negative charge inside the crystal. To maintain change neutrality, a negative ion moves to the crystal surface, creating a negative ion vacancy at its site. NaCl, CHCl etc. exhibit Scotty defect. The formation of vacancy is restricted in the following field. This is the vacancy. Okay. Next is Frankel defect. It is a special case of vacancy and interstitial defect in ionic crystal. Definition: when an ion displays from a regular location in the crystal lattice to an interstitial location in the crystal lattice, then this type of defect is called Frankel defect. Consider the periodic distribution of positive and negative ions in an ionic crystal. When a positive ion leaves its site and settles in an interstitial position, then it creates a vacancy in its position. Thus, a vacancy and interstitial defect are created. This pair of defect is known as Frankel defect. In case of Frankel defect, also charge subtlety is empty. AgBr, AgCl, ZnS, etc. exhibit Frankel defect. The formation of Frankel defect is described in the following field. So here this is missing and here this is missing. This is positive defect, this is your Frankel defect. This is positive, this is negative. Next is your substitutional defect. When an impurity atom occupies one of the position of the parent atom of the crystal, then such a defect is known as substitutional defect. A substitutional impurity atom is an atom of a different type than the bulk atom. Usually substitutional atoms are close in size within approximately 15% to bulk atom. The formation of substitutional impurity defect is shown in figure. This is the foreign atom. Zinc atoms are substitutional impurity atoms that are added to copper to make brass. In brass, zinc atoms are with radius of 0.133 nanometer have replaced some of the copper site of radius 0.128 nanometer. So here the size of the atom is almost same, that's why it is called substitutional. And here size of atom is not same. Okay. So this is we have negative ion, sorry positive ion here. So this is with negative ion. So this is its positive defect. And here this is the this atom has shifted here. Here Frankel defect. Okay. So here this is missing, pair is missing, that is positive defect. Here one of the atom has displaced its position, that is Frankel defect. So you can read these also. I have downloaded it from internet. You can also refer internet. So here pair of ions are missing. So that defect is Scotty defect. Okay.